All right, so here's your warm-up today. Number 1 is asking you to just solve this. 8x plus 16 equals 24. Hopefully this is a review from Algebra 1, but it's a two-step equation. Your job is to get x by itself. So why is x not by itself? Well, it's times 8, right? You also got this plus 16 just floating over here. So the first thing I would do is get rid of the 16. It really has no purpose. It's not attached to this x at all. Let's just move to the other side. So you start off by subtracting 16 from both sides there. And then on the left, you just have 8x left, because that's the whole point. 16 minus 16 is nothing, right? On the right, 24 minus 16 is 8. So you have 8x equals 8. And then you ask yourself again, why is x not by itself? It's times 8. So how do I undo multiplying? I undo it with division. So to undo this times 8, I will divide both sides by 8. 8's canceled, they leave a 1. Anything divided by itself is 1. 8 divided by 8 is 1. And same thing over here, 8 divided by 8 is 1. So I have 1x equals 1, or just x equals 1. Pretty straightforward right there. Okay, try another one, number 2. We got negative x plus 7. And that equals 2x minus 9. Now this one's slightly more difficult just because the x's are on different sides. So your job is to get all the x's on one side and all the other stuff on the other side. Doesn't really matter which side you want your x's on, left or right, pick one. Okay, we're gonna put all the x's on the left. Well, I got a 2x over here, it needs to be moved to the left. Now it's a positive 2x, so to get rid of it, I'm going to subtract 2x from both sides. Over on the left side, I had a negative x. I'm subtracting 2 more x's. What would that be? Negative 3 x's. And then over on the right, it's gone by design. That's what I was choosing to do. Now, if I'm choosing to put all the x's on one side, I better put all the other stuff, all the numbers on the other side. So we got to move this 7 to the right side. It's a plus 7. We'll undo that with a minus 7 on both sides. And we're left with negative 3x. Over on the right, negative 9 minus 7. Anybody got that for me? Negative 16. I'm down with that. Good. All right. So we got this. Cool. It's getting smaller. That's good. Your work should kind of get smaller as you go. You should be narrowing down to an answer. So we have negative 3 times x. Well, we don't want this negative 3 times. So we'll undo the negative 3 multiplied by x by dividing both sides by negative 3. And those cancel out, and you have x's, and a negative divided by a negative. I can clean that up. That's a positive, right? 16 divided by 3 doesn't reduce, so we're done. 16/3 is our final answer on that one. Now, probably the only thing that's going to trip you guys up, if memory serves from every year I've ever taught in my life, is fractions. Fractions are usually what kill students, so let's practice using some fractions here. It will be no different. We'll just be having to deal with fractions. 1/3 x plus 27. Okay. Anybody got any suggestions of where to start? Anything at all? That's why you got that 100, isn't it? Distribute. Yes, let's distribute that half in. So half comes into everybody. Now, half times, I'll draw some arrows. We're kind of going for the first time. So this half gets distributed to everybody. A half times 2x. Well, half of 2 is 1, right? So I just got 1x. So that's just going to be an x. A half times 4. Half of 4 is 2. Now, the sign was a minus, so I still have a minus. And then you got your 2. Equal sign, equal sign. And same thing on the right. I got this 1/3 times this expression. I will distribute the 1/3 to everybody. 1/3 of 9 is 3. So I have 3 x's. 1/3 of 27 is 9. So we have this here, and fractions are no longer an issue in this particular problem. But we got all the x's on one side and all the letters on the other side, numbers on the other side. Let's put the x's on the right this time for no good reason. Doesn't matter. I'll move this x over. We'll subtract the x from both sides. So over on the left, the x's are gone. X minus x, just like 7 minus 7 or 8 minus 8 is nothing. You still have a negative 2. Over on the right, 3x minus an x would give me 2x's. Now I got this plus 9. If this is too easy, you're welcome to do multiple steps at once or something like that. Okay, well, I'm putting the x's on this side. I'm going to put all the numbers on this side. I got this 9, so let's move it. Let's subtract 9 from both sides. On the left, -2 minus 9 would be -11. That equals 2x now. And then lastly, I have 2 times my x. I don't want this 2 times. I will undo the multiplication with division. So x is, and again, this doesn't reduce, so it's just -11/2. It is what it is. So that one wasn't so bad, because once you distributed the fractions in, the fractions were gone. There were no more fractions. This one is the same idea, only it's not going to be quite so pretty. So here we go on number 4. We got -1/4 times the entire expression, x plus 5. And that equals 1/5 times x minus 15. All right, let's get distributing. Okay, it's not going to be pretty, though. So same idea. -1/4 goes into both of these. Now, -1/4 times x is just -1/4 x. So -1/4 x. -1/4 times 5. It's not pretty, but if you think of 5 as a fraction, 5 over 1, how do you multiply fractions? Straight across, right? So -1 times 5 is just a -5. The 4 times the 1 is just a 4. That should make sense. If I have 5/4 and I have 5/4, that's what 5/4 means. It means I have 5/1/4 right there. Over on the right, we'll do the same kind of deal. 1/5 distributed into everybody. 1/5 times x is just 1/5 times x. We got lucky on the next one. 1/5 of 15 is clean. 1/5 of 15 is just 3. So we have 1/5 x minus 3. Yes. All right. Well, even though it's fractions, the theme is going to be the same. We're going to get all the x's on one side and all the numbers on the other side. I'm going to move this x over to this side just because I like pauses. So I'm going to add 1/4 x to both sides. Add 1/4 x to both sides. And then on the left, well, you had -1/4 x plus 1/4 x. Those cancel out, right? So really, you just have -5/4 remaining. And then over on the right, ooh, I have 1/5 x plus 1/4 x. How many x's is that? Side problem. What's 1/5 plus 1/4? Well, how do you add fractions? You need a common denominator. So you multiply this one on top and bottom by 4. Multiply this one on top and bottom by 5. And when you add fractions, you just add the tops only. So that is a grand total of 9/20. So what's all this mean? Well, 1/5 of an x plus 1/4 of an x is apparently 9/20 of an x. Took some work, but we figured it out. So this is about as it's going to get as far as the speed of your problems goes, because it's just dealing with fractions. All right, I put all the x's on this side. I put all the other numbers on the other side. So I got this -3. So let's get that over to the other side. Let's add 3 to both sides. Well, dang it. Now I got to figure out what -5/4 plus 3 is. Side problem again. -5/4 plus 3. Well, 3 is 3 over 1, right? I got to get a common denominator. So I'll multiply this one on top and bottom by 4. That would make this 12/4. That's equivalent, right? That's still 3. And -5/4 plus 12/4 would be 7/4. So this side is going to be 7/4 after all that work. And over on the right, we have 9/20 times x. All right, we're almost there. Last thing to do is get rid of this pesky 9/20. Now, what does 9/20 mean? If you ignore the divide by 20, this is 9 times x. How would you get rid of the 9? You'd divide by 9, right? Okay, ignore the 9 for a second. You have a divide by 20, right? How would you undo dividing by 20? Multiply by 20. So let's do it both in the same step. On this side, I need to get rid of this 9 on top with a 9 on bottom, and to get rid of the 20 on bottom with a 20 on top. So I'm going to multiply this side by the, what's that word? Reciprocal. That's the fastest way to get rid of any fraction, multiply by the reciprocal. Of course, if I multiply this side by 29ths, I got to multiply this side by 29ths also. Over on the right, by design, 29ths of 9/20ths, the 20s cancel, the 9s cancel, you just have x. So x is going to be whatever this junk is. Let's clean it up though, multiply straight across. That's how you multiply fractions. 20 times 7 is 140. 9 times 4 is 36. So there's my answer, although I think we probably could reduce that. I think 4 goes into both of those. I won't bore you with the details of it, but I believe it's 35/9 right there. So there's my final answer. Nothing goes into 30, nothing goes into 35 or what? 5 and 7, they don't go into 9, so that ain't going to fly. So there's all the work for that, and multiply by 29s and all that good jazz. All right, let's do some LGs and get our lesson going. I'm excited for a new unit. That last one was long. Had a lot of stuff in it. Let's cleanse the palate. Learn about solve linear equations either graphically or algebraically. By algebraically, they mean the way we just did it. We're actually going to solve problems and move things around and solve for them. Of course, you always want several ways to solve things. You want to be able to do it with your brain, just straight up on the whiteboard or a piece of paper, just doing equations and stuff like that. But you also want to have a graphical understanding of how to solve things and have graphs that back up your understanding. Lots of redundancy systems, lots of ways to check yourself and make sure you are getting the correct answer. Also, linear inequalities. This is not shading stuff. This is just all one variable stuff. There's no y equals x stuff. It's just x stuff. X, x, x. X equals this. X is greater than 2. All these graphs will just be on a line. It won't be a region. It'll just be shaded on a line. Actually simpler than what you just did. With new content comes new homework. So there is a new thing out there on Reveal called Homework 2.1. You got the normal 2-day thing. Today's Thursday, right? So it's not due until Monday. So you got the weekend also, but tomorrow's a work day. So hopefully you'll have plenty of time to get that done before even the weekend starts. All right, here we go. Homework 2.1. This is a new unit. New unit. Big new heading in my notes. Big new heading. Unit 2. We'll be here a while. Couple weeks, 3 weeks, something like that. I'm kind of glad they have this unit. It's a nice review of Algebra 1. This should not be anything you have not seen before. Although it does get a little bit more complicated. It talks about eventually in the unit how to solve absolute value equations and all kinds of other stuff that is randomly thrown in here. But the main thing will be just how to solve problems like the ones in the warm-up today. Specific to today, our topic is section 2.1. I don't think you need to write down the title, maybe just section 2.1 or something like that. That way you know, hey, this is what that section's from. If I want to go back and study when the test comes, I can go to the textbook and look it up. Right on page 73. And let's go ahead and dive in. Here we go. Okay, so first thing, I would not write this down. I would just think about it for half a second. An equation is a sentence where two things are equal, right? So this side is equal to this side. I remember when I was growing up, you know, I thought of like a balance at a supermarket. You know, you got fruit on one side and fruit on another side. And oh, if I would need to double this, I could have 2 more fruit to double if I had 2 already, right? And if I had 3 over here, I'd have to double that. You know, that way they kind of balance it out all the time. But the key thing is you can do all kinds of things to both sides as long as you do it to both sides. You can add something to both sides. You can subtract something to both sides. You can multiply both sides by something. And you can divide something, both sides by something. What's the only thing you can't divide by in math? Anybody know? 0, right, exactly. So never, ever, ever divide by 0. That's bad practice. In fact, I would strongly recommend you never multiply through by 0 either. But you have your normal properties right there as far as how to solve things. All right, we don't need to do this one, but let's at least look at the example here. It's just like our warm-up was. This is a linear equation. What's linear mean again? Line, right? And remember, that means everything's raised to the first power, correct? Y is raised to first, x is raised to first. Well, if you look at these equations, you only just have x's, right? There's no x squares, there's no x cubes, there's no absolute values of x's, there's x's. That's what makes all these things linear right here. But if you have 1/3 times expression, what should you do? You should take the 1/3 and distribute it in, right? So what should go in this blank right here? You have the 1/3 times the 2x, that's 2/3 x, right? Right here, I have 1/3 times 57, that'd be 57/3. So guess what goes in that blank? 57/3. Right here, if you distribute the 1/3 in, what's 1/3 times 6, anybody? 2, isn't it? 1/3 of 6, or 6, because of the 3 pieces I have 2. So that'd be a 2 right there, correct? And then you move things around. Now you have 2/3 x's minus 1/3 x. That'd be 1/3 x, correct? And there's a bunch of other blanks and stuff like that, but I won't bore you with the details. Just watch the fractions. That's my main thing right here. Here's another example. The diameter of the Earth. That's just practicing writing an equation, and I will actually do this one with you. So you might want to write down example 2. We won't write it, go very quickly, but if you want to go back to the book someday and say, what was example 2? Here it says the diameter of Earth is 828 kilometers less than twice the diameter of Mars. If Earth has a diameter of 12,756 kilometers, what is the diameter of Mars? So how would you set that up as an equation? Well, what would you say? The diameter of Earth, what letter do you want to have for the diameter of Earth? E, makes sense to me. Okay, so the diameter of Earth is, whenever they say is, that means equals, right? Is 828 kilometers less than twice the diameter of Mars. Now, what's the twice the diameter of Mars? Well, twice of the diameter of Mars. I assume we'll use m for that. Makes sense, right? Diameter of Mars. There's twice the diameter of Mars, but it's 828 kilometers less than that. So how do I make something less than this? I subtract it, right? I got twice the diameter of Mars. I'm going to subtract off this 828. So here's a master equation for the relationship between the diameter of Earth and the diameter of Mars. But then they go on to say the Earth has a diameter of 12,756. Which letter was the diameter of the Earth? It was E, right? So I can replace E with 12,756. And once we've translated all that talky talk into an equation, it's actually very straightforward. All you got to do now is get the m by itself. So you'll get rid of this minus 828 first. So first thing I would do to get rid of a minus 828 is do a plus 828. But of course, I got to do it to both sides. I would recommend using a calculator on this side, but I'm going to try to use my brain. We'll go old school on it. Let's carry and stuff. 6 plus 8 is 14. Carry the 1. 1 plus 5 plus 2 would be 8. 7 plus 8 would be 15. Carry the 1. So finally, we have this equation. 13,584 is 2m. And lastly, all you got to do is, well, I don't want 2m. I want just m. So I have 2 times m. We'll undo this 2 times with a divide by 2. And when you get done, m is going to be whatever this is divided by 2, which is, 6. I don't trust myself. It's a lot to do in your head. 6, 5. Yeah, 6, 7, 9, 2. So there's my answer for that one. If you are doing a word problem, it's always good to go back and say, okay, what's a good unit for this thing? That's the diameter of Mars. Diameters are distances. What distances are mentioned throughout this problem? Kilometers, right? So I would say 6,792 kilometers on that particular problem. Okay, they got lots of other examples too. Just kind of, sometimes you just want to solve for a variable when there's other variables. Here's example number 3. We can do this one too. It gives you the formula for the perimeter of a parallelogram. Not that it matters too much. Most of the time you can cut through the talk and just write down what they gave you. Here's an equation. We'll write it down. I don't need to read really what it's about. Where A and B represent the measures of the bases, not that it matters. Solve the equation for B. That's the key thing it says. Solve the equation for B. Now, how can you solve it if there's not a bunch of numbers solved around? Well, the process will be the same. This is a number, this is a number, this is a number. I can still move them around like normal. You want to solve for B, which means what? Get B by itself. So we're going to get B by itself. So I ask myself the same questions. Why is B not by itself? Well, over here, I have this 2a, which really has nothing to do with it, right? So we're going to get rid of 2a. I'm going to subtract 2a from both sides. Now on the left, I can't do anything with this because it's letters, you know. So, but I have a p minus a 2a, so I still have a p minus a 2a. There's really nothing I could write about it. I'm almost there. I got 2 times b, so how are we going to undo times by 2? We're going to divide by 2, both sides. I'm going to really hit that word hard all year long. Sides. Do it to both sides. So divide this entire side. Make sure you put a bar. The whole thing divided by 2. And that's a pretty good final answer. Well, you could do a little bit better. If I gave you this, I hope you would think to distribute, correct? Okay. Now, here's something I want you to get used to, okay? If you can do something with multiplication, you can also do it with division. So if I can take something times a couple things and times them both, guess what? If I had a couple things divided by them, I could both separately divide them by the number. So right here, p divided by 2, well, I can't really do much with that. I'll just call that p divided by 2, or another way of writing that is a half of p. The reason why I want to distribute this is because, oh, what about 2 divided by 2? Is that pretty? Yeah, it is. Okay, that's just going to give me a minus and an a. So probably that's the most mature answer right there. Half a p minus a would be my solution for that. And down here, a second example you see on the board, a quick check of yourself. Just look at it real quick. We don't have to go over it, but look what they did. They were trying to solve, oh, they're just trying to, well, just look at their work. It's actually pretty solid work. Notice what's the first thing they did here? They multiplied both sides by what? What's the difference between this line and this line? Well, I guess it's frozen. What's the difference between these first 2 lines? There's a 2. Why would they put a 2 there? Anybody got any suggestions why they might do that? Yeah, everybody's saying the same thing. I like that. Get rid of that half, right? There's nothing wrong with that. That's entirely okay. In fact, if you had a problem, this is probably a really good tip for you. If you hate fractions, how many people hate fractions? Probably all of you, right? Okay. If you hate fractions, how do you get around them, by the way? Well, let me put this on the board for the people at home. Let's say I gave you this equation. This is gold right here. In fact, let's write this one down. Let's write this down. This is going to be helpful. It's going to be helpful for you guys. Because you hate fractions, right? I would strongly suggest you don't avoid fractions your whole life. I mean, there's tricks to get around them sometimes, but you got to deal with them. Let's say you had this. And you don't want to distribute those fractions in, because I don't want to do with a 4th x and a 4th and a 5th x and a 5th. That's just too much. I got to get common denominators. It's terrible. Well, let's get rid of these fractions. This is a divide by 4, correct? So how do we undo that? By a times 4. So you could take both sides times 4. Let's go ahead and do that first. Of course, if you do it to one side, you got to do it to the other. And you see what happens. You have a 4 times 4, which is just 1, right? Congratulations. That fraction is now not a problem anymore. But I still see another fraction on the other side, don't you? I see this 1/5. Well, that irritates me too, right? Well, it's just a divide by 5. So let's undo this by multiplying by 5. So I'll multiply this side by 5, which means I also have to multiply this side by 5. What's left on the left? Well, the 4 things are gone, right? I got a 5 times x minus 1 remaining. Over on the right, I know I put it in a different spot, but don't you have a times 5 over here and a divide 5 right here? So what do? They cancel out also. And you're left with a 4 times x plus 1. I think you'd probably rather solve it from there, correct? Than the original way with distributing the fractions and dealing with common denominators. So if you hate fractions, you want to avoid them like the plague, I suggest you multiply through by the bottoms, and then they're taken care of. In fact, that's like a whole unit we'll do someday, is how do you deal with x's on the bottom? You guys probably solve this right now. Here's an equation, 1 over x equals 2. Don't freak out. You hate fractions? Yeah? What's this got? Divide by x? How are we going to do that? By multiplying both sides by x. Does that look more friendly to you now? Yeah, you could solve that. Yeah. So there's lots of ways to get around all the fraction problems, and we'll discuss those as the course unfolds. But That's probably enough for that right there. Okay, next little piece of vocab, and I do want you to write down this box at the bottom here is all this stuff they're calling things. How do you solve something by graphing? First thing you need to know is that there are about 4 different words for the same exact concept. In fact, I probably threw you off on your calculator because on the test, I probably asked you to find an x-intercept. And you had to go to second calc and hit zeros. It's like there was no button for x-intercept. Well, there's lots of different words for the same concept. 0, root, solution, x-intercept, they all mean the same thing, and people use them interchangeably. So you got to know what that word means. It's where a function equals 0. I will use the term zeros probably more than anything else. I'll say, let's go find the zeros. Let's go do this kind of stuff. I probably won't say the word root. Probably won't say the word x-intercept. That was just kind of from the first unit. The reason it's called a zero is because, or an x-intercept, right? That's what that means too, right? Where it crosses the x-axis. But it's called a zero. We'll do that more often because it's where the function equals 0. What's the y value right there? It's 0. That's the whole concept behind it. We're going to be obsessed with that in this class. No matter how complicated the graphs get, we're obsessed with finding out when it's equal to 0. 0, 0, 0 all year long. When is something equal to 0? So how do you actually use this to solve something like an equation? Well, this bottom box down here at the very bottom is kind of like your cheat sheet of how you would go ahead and use a graph to solve an equation. You set the equation equal to 0. You replace your 0 with f of x or y. You go graph it, and you see when it equals 0. It's very simple. If you're done writing down things, you might as well get your calculator out because we're going to do graphing 1 in a second. This will be a big theme of ours. You're going to be all year long looking at your calculators and trying to figure out where it crosses the x-axis, where it's 0. When we study quadratics, it's entirely going to be about where it equals 0 and 0 and 0. It's just going to be so much to death. It's going to be gross. All right, what do they mean by set the equation equal to 0, replace it with f of x, etc.? Well, here's what we're going to do. Let's do this example real quick. Example number 4. This is not a graph. This is just straight up an equation. It says negative half x minus 11 equals negative 8. I don't see any y equals. How am I going to graph? I can't graph this thing. It doesn't say y equals anything. So how do I graph it? Well, here's the steps. First things first, you are going to set it equal to, what's the magic number? 0. Okay, so how do you set it equal to 0? Well, there's lots of ways. The main thing is you just want one side to be equal to 0. I think the easiest thing to make one side be 0 is just get rid of this negative 8. Would you agree? So let's add 8 to both sides. Add 8 to both sides. So now you got negative a half x minus 3, negative 11 plus 8 is negative 3, equals 0. Seemingly no help. It's like, well, why'd you do that? It's stupid. Well, here's what you're going to do. You want to know when this thing is equal to 0. You give this thing a name. I don't care what you name this thing. You can call it y. That's fine with me. You can call it f of x. It really doesn't matter what you name it. You just call it something. We're going to study this thing, 1/2 x minus 3. What am I obsessed with? I'm obsessed with when this thing is equal to 0. So let's go graph this thing and see when it equals 0. That makes sense. Oh, yeah. I get that. Good practice. You'll also find that the things we talked about from the first test with using your calculator are just going to keep following you around and around and around too. So, you know, you can always be finding zeros and extrema and all that kind of jazz. So you go to f of x. You do 1/2. How do you do a fraction? We used to divide. So 1 divided by 2 1 divided by 2 times x, that's a half times x, minus 3. And then again, I'd always hit zoom 6 just to reset it. Chances are it was already reset, but you're okay. So here's this thing I'm studying. It has lots of different values. Some x value, it's got a y value down here. Some other x value, it's got a y down here. But what am I obsessed with? I'm obsessed with the value of this thing is equal to 0. So where's it equal to 0? Basically where y is 0, right? I named this y, right? Y is this thing. I want y to be 0. That's the x-intercept, correct? Or better known as a 0 or anything like that. So how do you find the x-intercept? Don't guess. Go to second calc. And as you should know from your last test, 0 is the option you're looking for here. You're looking for where it crosses the x-axis, so you pick a 0. You move your cursor anywhere to the left where it crosses the x-axis. Here's where it crosses. My cursor is definitely to the left. It's fine by me. I hit enter. It asks you for a right bound. Move your cursor anywhere to the right of where it crosses the axis. I think I'm safe. Looks good for me. Hit enter. Guess doesn't matter. You just hit enter again. And then boom, it tells you what the answer is. The 0 is at x equals 6. So the answer to this thing is x equals 6. We didn't have to go, yeah, go ahead.
When I put it in, I put graph,
Window range. Quick. That's why I always suggest you do that zoom 6 option at first. It'll reset everything to nice, clean factory stuff. Zoom number 6. Just get in the habit of doing that. I'm going to graph, I'm going to hit zoom 6. Going to reset everything, and life is good. Okay, so there's my answer. Now, does it actually work? Well, let's go back and check it. Here was the original problem, correct? And hopefully 6 solves this thing. So what's a half of 6? It's 3, right? 3 minus 11 is, in fact, -8. So it all checks out, and life is good. That's kind of all there is to that stuff. They probably got another one. Let's see. It wasn't good enough. Let's do one more example. One example ain't good enough. Let's do 2. So here's another random thing. We'll call this example 4.5. Something like that. I want you to go solve this equation. 1/7 x plus 2 equals 9, something like this. I don't know. 1/7 x. Yeah, so again, what's our strategy? We're going to compare this to the magic number of 0, right? So I don't care where you put things, but get one side equal to 0. I think the fastest way would be to subtract the 9. We'll subtract 9 from both sides. When you do, 2 minus 9 is -7, so you have 1/7 x minus 7 equals 0. I want to know when this thing equals 0. So I'll go graph this thing. In fact, you don't even have to name it if you don't want to. Just cut right to the chase. Go to your calculator. Y equals, clear it out. 1 divided by 7 times x minus 7. And here we go. Zoom 6 is always a good idea to start looking in the normal spot. Here it comes. Well, I don't see it crossing the x-axis, do you? But you got to use your imagination. What's this line do? It just keeps creeping up, right? So what do I need to do? I need to look farther to the right. Would you agree with that? Okay. Now, how do you tailor things? You go to the window button up here. You want to look farther in the x direction. So you want the x max. Max is this is the left side, x min. This is the right side, x max, to go higher. I don't know. What do you think? How far do we need to go? Let's go crazy. Let's go 50. See if 50 cuts it. This is really just an art at this point. There is no set way to know what your window is supposed to be. You just keep graphing it, and hopefully you see what you need to do eventually. Oh, it crosses. It seems like it crosses about 50, right? I'm going to go a little farther out. I'm going to go my window. I'm going to go out to 100. And hopefully it's really clear now that it crosses the axis. Let's see. Oh, I definitely see it crossing the axis now, don't you? Okay, so let's do second calc. What's this thing called? A 0, right? Looking for 0, so you hit number 2. Move your cursor anywhere to the left of it. Doesn't matter where. Hit enter. Move your cursor anywhere to the right. Doesn't matter where. Hit enter, and when you hit guess doesn't matter, hit enter, and then you get your answer 49. There it is. There's your answer. So the solution to this thing is x equals 49. So that's how you would do it graphically. Do not rely on just graphing everything. It's not going to cut it in this class. You need to know how to do it both ways. You need to graph things. You need to know how to go do it with an equation too. So that's very, very, very important. All right, last idea for today is now just about graphing an inequality. And this is going to be very, very straightforward. I don't think there's anything on here that we haven't discussed about previously in the course, okay? Especially this note down here. I harped on that a lot already, right? When you multiply or divide an inequality by a negative, what do you got to do? You got to flip it, correct? Okay. If you remember that, then everything else about solving these is the exact same thing as with equations. I might have 2 different ways to write it, or 3 different ways to write it, or something like that. First off, your homework will probably be harping on this thing called set builder notation. Let's draw this little picture. This is what your answers are going to look like. Okay, they're going to be shaded regions on a number line. And the normal business, if you have a closed dot, what's that mean? It includes it, right? Okay, and that's a bracket, correct? Bracket, if I'm going to write it out in words on a board or something like that. If it's an open dot, then it's a parenthesis, correct? Doesn't means it doesn't include it. Same rules as before. They might write this weird. What's this graph really saying? I'm looking for everything greater than 1, right? Everything greater than 1 is shaded in. They might want you to write it in set builder notation. I won't have you do that on the test. I think set builder notation is kind of pointless at your age. But if you remember what this means, we kind of did talk about this a little bit last thing. What's this mean? It means all the x's, and it gives you a bar, but then the condition comes, where x is, that messed up, x is greater than 1. That's all that thing means right there. So I got the bar there. It says, hey, give me all the x's where x's are greater than 1, which is what the graph is saying, right? It's just all the x's are greater than 1. So it's just a fancy way of saying what that thing's saying. You know what I want, though. What I want on your test is the interval notation stuff. I want the brackets and the parentheses. So when your test comes, I probably will say, oh, yes, I want you to shade it on a number line, but I also want you to tell me an interval notation with parentheses and brackets and stuff, what that means. And again, what's the 1 to infinity mean? The parentheses means it doesn't include it, right? 1's not included on the picture, correct? And it has everything from 1 to infinity, so 1 to infinity right there. You're just basically going to shade in what the inequality is talking about. Nothing too complicated. All right. Let's look at a couple examples of these things now. All right. So here's an ugly thing. We'll do it, though. Let's write the whole thing down, practice it. Why not? I'm going to do the exact same thing on this I've been doing on everything else. I'm just going to be very conscious that since I'm dealing with inequality, if I multiply or divide by a negative, I have to flip it. If I can remember that, life's going to be good. All right, here we go. So negative 5.6n plus 12.9. This is like the one time you probably could use decimals. I want you to avoid decimals at all costs. But if they give you decimals, it's a gift. You can just use decimals for everything. Greater than or equal to negative 71.1. All right. So how are we going to solve this? I'm going to pretend like it's an equation. I'm going to get the variable by itself. Okay. So why is this not by itself? Well, there's this 12.9 sitting over here for no reason, correct? Let's get rid of it. Let's subtract 12.9 from both sides. And over on the left, it's gone. Sweet. I still have this negative 5.6n greater than or equal to, now I got to figure out what negative 71.1 minus 12.9 is. You can definitely use your calculator for that if you want. But it turns out to be nice and clean. It's negative 84. I should check my, yeah, negative 84. Okay. Well, now, why is this not by itself? It's times this negative 5.6, right? So we're going to divide by negative 5.6, but it's an inequality. It's negative, right? So make sure when you divide both sides by the negative 5.6, I just divided by a negative. So dang it, I better take that inequality and flip it, okay? Multiply or divide. And now I got to figure out what negative 84 divided by negative 5.6 is. I can't do that in my head. It's going to be positive, right? Negative divided by a negative. Oh, that's clean. That's nice. Okay, 15. So n's less than or equal to 15. So there's your answer, okay? And there's nothing wrong with that. All right, let's get a visual. On the number line, what does that look like? Well, normally it's x's, right? But n's, x's, who cares? It's whatever we're doing. Anything less than or equal to 15. So you go find 15, right? On the number line, should I have a closed dot or an open dot? Closed, very good. Okay, because it can equal 15, right? So nice, big, clear to your teacher kind of filled in circle there. And all the ones less than it. So things less than 15 are over here. And you would literally be shading to the left with an arrow saying, hey, 15 and everything less than over on that direction. In interval notation, what does this shaded region mean? It means everything from how far to the left? Negative infinity, all the way up to 15. Make sure you're always doing it left to right, okay? A lot of you guys on your test would write something like this. 15 to negative infinity. Now, I let you go on that because you're new at it, you know. But is that in the right order? No, it's left to right. So when you write this, I let you go on the test. But in the future, I'm going to be a little bit harsher on it. You want to write like that. Negative 15, negative infinity coming into 15, left to right like that. So all these are the same thing. That's saying the same thing as that, and that's saying the same thing as that. They're all equivalent, just different ways to write it. Make sense? Makes sense, right? It's not that complicated. All right. We got anything else? Nope. That's it for the day. So you guys have your homework to work on. Homework 2.1 is due on Monday. Don't have any work time today, really, but tomorrow the entire class period is dedicated to that. And hopefully I'll be able to hand your tests back to you tomorrow. But I want to make sure everybody's is graded before we do so. Have a good day.